Hello everyone. My name is Pirjade, and this is my ISC video presentation of course Open Elective Industrial Management and Operation Research. So, my topic of presentation is optimizing job processing in operation research. Uh, this is a title, and the problem which comes under this is processing of n jobs under three machines. So, an operation research leverages advanced analytical methods to optimize the processing of jobs or tasks through complex system. This introduction explores the fundamental principle and strategies for efficient managing job flow across multiple machines. The three machine problem for optimizing the n jobs. So the machine one, the first machine performs the initial processing step on raw inputs or material. The machine 2 involves building upon the work done in first step, transforming the input further, and lastly the final machine completes the job, delivering finishing the product or the output. Now, the assumptions and constraints that are necessary to take care upon while solving the n job problems using on three machine. So the first one is job order. Jobs must be processed in a specific sequence with no interruptions or jumping ahead. The second one is machine capacity. Each machine can only handle a limited number of jobs at a time. And lastly, the time limit. There may be strict deadlines or time constraints for completing the overall job processing. Also, the sequencing and scheduling strategies that are involved in the solving of n jobs using three machines are the job prioritization, machine allocation, and time optimization. In job prioritization, we determine the order of jobs based on factors like due dates, resource availability, and processing time. And the second one is the machine allocation. Assign jobs to specific machines in a way that minimize waiting times and bottlenecks. Lastly, time optimization. Adjust the schedule to reduce overall processing time and meet deadlines. Uh, in optimizing job processing, we can look up to throughput maximization, waiting time reduction, and bottleneck eliminations. In throughput maximization, we can increase the number of jobs processed per unit time, improving the overall efficiency. In reducing the waiting time, we can minimize the time jobs spent ideal waiting for the next machine to become available. And for bottleneck elimination, we can identify and address any constraint or bottleneck that limit the system's processing capacity. So the practical applications and case studies that can be implemented by using n job processing by using three machine is are manufacturing, construction, and healthcare. These are the sectors where where we can use the operation research concept. So in manufacturing, we can optimize production schedules and jobs flow in factories and assembly lines. In constructions, we can manage the sequencing and time of task and resources on construction site. In healthcare, we can streamline patients flow, optimize utilization of medical resources. So now we will see the how we can actually solve the n job problem on three machines. So we have the jobs like A, B, C, D up to G, and we have three machines, and the time required for each job on each machine is given in minutes. For converting for solving the three machine problem for n jobs, we have to have focus on the two constraints, such as the smallest time for the machine. So the smallest time of machine 1 should be greater than equal to the largest time on machine 2, and the second one is smallest time on machine 3 should be greater than equal to largest time on machine 2. So for converting a three machine problem into two machine problem, one of these two constraints has to be passed. So if the second so if we look upon first condition, the smallest of machine 1 is 3 and the largest of machine 2 is 5. So 3 is not greater than equal to 5. The first condition fails. So if we go for second condition, that is smallest on machine 3 is 5 and largest on machine 2 is 5. So the second condition satisfies. So we can convert the 3 machine problem into 2 machine problem. So after converting a 3 machine problem into 2 machine problem, the problem will look like this. So after converting a 3 machine problem into 2 machine problem, we have to find the sequence. So if we look for the smallest time, that the smallest time will be 6 for job E, which is on machine 2. So we will put it into the last of the sequence, and similarly we can calculate for all the remaining jobs in the sequence. So the sequence will be A, D, G, F, B, C and E. After doing this, we have to prepare a chart which consists of input time, output time, processing time and ideal time for each machine, such as machine 1, machine 2 and machine 3. So after calculating the all these times and preparing the table, the final table will look like this, which contains all the in time, processing time, out time for each machine A, B, C respectively, and for the sequence, that is A to E, will be same for all machines. So the total ideal time for machine C will be 7 minutes. The total ideal time for machine B will be 37 minutes, and the total ideal time for machine A will be 13 minutes. As we can subtract 46 from 59, so it will become 13. We subtract 47 from 15, it becomes 12, and additionally the sum of the ideal times, and the lastly the ideal time for C will be 7 minutes only, and the total elapsed time for processing all the jobs on all the machines will be 59 minutes. So that's all about my presentation on the processing of n jobs on 3 machine. Thank you so much.